Okay, yes, hi students, very good afternoon everyone and welcome once again to Om Institute and welcome to the next session on the Engineering Services PYQs. Okay, this is the Signal and System part number 2. You already took Signal and System part number 1 wherein we focused on the questions based on LTI systems, especially convolution, discrete time and continuous time as well. And at the same time, we also looked into some important questions with respect to Fourier transforms. Okay, the continuous time Fourier transform as well as the DTFT and DFT. Okay, so with the engineering services PYQs only. Okay, and this is the next session where I told majorly we are going to target the questions from Laplace and Z transform. Okay, that's what I again say. So this session majorly will be targeting the questions of the engineering services previous year questions. Okay, from the Laplace and the Z transform. And time to get started, guys. This is the first question. What is the Laplace transform? Hi, very good evening, everyone. Good evening, Shanti Swami. Good evening, others as well. Sorry, I would say good afternoon at this point of time. Okay. Yeah, anyways. So what is the Laplace transform? See, again, many questions of Laplace are direct formula and result based that you know, like, okay, the standard formula t power n, t raised to the power n, e power minus at ut. What is the Laplace transform is given by factorial n is divided by s plus a raised to the power n plus 1. Factorial n divided by s plus a raised to the power n plus 1. Okay, so it is t square. If it is t square, it should be factorial 2. Okay. Oh, then the options are in n. So I think maybe, sorry, I think there's a typo error in the question. The question itself is t power n only. T power n e power minus at ut, because otherwise options should not be in the n form. Okay, so it's a direct formula then. Factorial n upon s plus a power n plus 1. Answer is the D. Okay, this is something that you must directly know. Okay. All right. Okay. Using this only, the next important formula, t power n ut. Sometimes they ask only the polynomial term, t power n, t square, t cube, t power 5, only polynomial term given. Okay, the Laplace transform is factorial n upon s power n plus 1. Just I have put a equal to 0. Correct now? Okay, next question. What is the Laplace transform of 1 minus e power minus 2t? 1 minus e power minus 2t. Yeah, Gyanendra, correct answer D for the previous one. Now 1 minus e power minus 2t. Okay, what is going to be the Laplace transform? 1. Laplace transform for 1 or step function will be 1 by s minus e power minus 2t, e power minus at 1 upon s plus a, e power minus at 1 upon s plus a, so 1 upon s plus 2. Okay, s plus 2 minus s, simplifying upon s plus 2. So s cancelled, your answer is simply 2 upon s plus 2. 2 upon s plus 2, option A. Okay, 2020 Engineering Services ESE question. Correct answer is option number A. Correct answer is option number A. Okay, next. If xt is delta 3t plus u3t, delta 3t plus u3t, then what are the Laplace transform and the associated ROC for the function of the time respectively? Okay. Right. Correct answer, Janendra and Shanti Swami for the previous one. See, if I take delta t plus ut, let me start with delta t plus ut. What should be the Laplace transform for? Because both have the equal scaling, 3t and 3t. So I'm just writing delta t plus ut. What should be the Laplace? We know for delta t it is 1. Impulse Laplace transform 1. Step Laplace transform 1 by s. That is it. Okay, that means it is rearranged as s plus on all those things. Okay, so we can write this as s plus 3 upon s. Oh, sorry, s plus 1 upon s. S plus 1 upon s. Okay, now what should be the Laplace transform for xt, which is given by delta 3t plus u of 3t? Okay, so Laplace transform time scaling property. See, if ft has the Laplace fs, for fat the Laplace transform is given by 1 by a, 1 by modulus a, f of s by a. Correct now? 1 by modulus a, f of s by a. Okay, so 1 by, what is a here is 3, delta 3t u 3t, it's a scaling by 3. Okay, we can call this as ft suppose. Okay, so this given function is f3t. Okay, so what is a is 3, so 1 by 3, okay, f of s by a. So this function you replace s by 3. S by 3 plus 1 upon s by 3. Okay, so 1 by 3 here, if I multiply throughout by 3, so s plus 3 upon s. S plus 3 upon s into 1 by 3. So s plus 3 upon 3s. Okay, now they are also asking the ROC. They are also asking the ROC. That also we can see easily. Okay, that also we can. I think expression wise also only one option is matching. Okay, expression wise also only one option matching. But what is the ROC? Now see, if you want to talk about ROC, see what is the only pole? What is the only pole? S equal to 0. Okay, so ROC has to be, ROC cannot include a pole, so it has to be right of origin or left of origin. But see the type of signal, UT or U3T. Okay, because the signal delta 3T, delta is a 1-point signal, but the other part is right-sided. U plus T means right-sided. So because right-sided signal, what should be the ROC that I will write is sigma greater than the pole location, that is origin, sigma greater than 0, or real part of S greater than 0. Option number D anyways, correct? Yes, Sandhi Swami, correct answer. It is D. It is D. Anyways, I think expression also is matching only in one of the option. Correct, na? Yeah, only in one of the option, expression is also matching. No problem. Next question. If xt is as shown in the figure, what is the Laplace transform? If xt is as shown in the figure, what is the Laplace transform? Hello, 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 hello. Yes, guys. Let me check. I think it should be fine now. Sorry, it took a little long time. It was not expected that power cut will happen and overload occurred. Now, okay. Yeah. Okay, guys. So let's continue. Let's continue our session. Let's continue our discussions. Okay. Yeah. So this is the question we were on to. If xt is as shown in the figure, what is the Laplace transform? So any waveform based, especially rectangles, triangles, or trapezium, you can break into step and ramp function. Correct. So the triangle directly starts with the straight line, that is the ramp portion. How much is the slope of this line? Okay, the slope of this line is going to be height, which is 10 divided by base, which is 5. Okay, slope is 2. And what is the slope of this line? Okay, the slope of this line, again, height is 5 and base is, sorry, rather height is 10, base is 5, but this is a decreasing line, so it will have the negative slope of -2. Okay, negative slope of -2. So how my xt can be represented here? My xt starts with a ramp signal having the slope 2. Okay, so 2r. Ramp has the unit ramp means slope 1, so I'll write 2r. But ramp starting from -5. Rank starting from -5. Left shifted ramp, rt plus 5. rt plus 5. Now, at this point, okay, the slope is going to change from 2 to -2. So how much is the slope change? How much is the slope change? -4. Okay, so -4 r of t. Because this is the origin. So at origin, I need to include a ramp signal having the slope -4. So that 2 minus 4 net slope is -2, because we know whenever ramps are added or subtracted, slopes are added or subtracted, correct? Then after this point, the slope is 0. After this point, slope is 0. So from -2 to 0, that means this time you need to add -2 to 0. That means you need to add the slope of 2. That is, to add slope 2, you need 2 into r. Ramp at which point? T equal to 5. So right shifted ramp. Right shifted ramp. Okay, so now let me write down the given signal here once again. Rather, I'll say obtained signal. What I have obtained, 2r of t plus 5 minus 4r of t and plus 2r of t plus 5. Sorry, t minus 5. Correct. So what is going to be the Laplace transform? Okay, dear, what is the Laplace transform for ramp? We know is 1 by s square. Okay, so 2 into 1 by s square. But time shifting property. Okay, exponential term will come up, e power plus 5s. Then -4, ramp signal 1 by s square Laplace transform, plus 2, again ramp signal Laplace 1 by s. Time shifting rt minus 5 to e power minus 5s as per the time shift property, correct? As per the time shift property. Now, solving it completely. Okay, denominator is whole s square. Okay, 2 can be taken common. Have they taken 2 also common? No, no need to take 2 common. 2 e power 5s minus 4 plus 2 e power minus 5s. Okay, so yeah, correct answer is option number B. Option number B. Right, dear? The very correct answer is the option number B. Okay. Next question then. Next question. This was 2018. 2023 Engineering Services ESE. This is a good question. I mean, decent, better than the previous one, I will say. What is the Laplace transform of the periodic waveform shown in the figure where A is 1? So, of course, if A is 1, 2A is 2, 3A is 3, 4A is 4, that we already know. But what is important is what is there in the 1 period. So, dear, look into this particular pattern. Look into this particular pattern. This is what forms the 1 period. Okay, this is what forms the 1 period. Okay, so rather I will create a separate waveform here. Rather, I will create a separate waveform here known as FPT. And by FPT, I mean 1 period information, because rest is repetition. What is the 1 period information contained in the given signal? So see that 1 period. Okay, it starts with the amplitude 1 up to A. A means 1 here. Okay, and then it has the amplitude -1 up to 2A. 2A means 2, and then again repeat. At 2A, it's again going to become 1. Okay, so I'll stop here. I'll make it stop at 0. Okay, so 1 and -1. Again, after that, 1 will start. Okay, again, after that, 1 will start, right? Practice, it's all about practice, Santi Swami. More you practice, everything settles into the mind. Okay, so yeah, dear, come up here. So this is the 1 time period information. Okay, so if dear, this is the 1 time period, this is again the same. This portion is same, this portion is same. Okay, so how can you express this particular signal? See, if this is FPT, this will be FPT minus T, T minus 2 actually. Okay, this starts at 2. This starts at 2, though, you know, this is similar because of periodicity. This is similar, but only right shifted. Okay, and periodicity means it will be there till infinity. Okay, it will be there till infinity. So what about this part? This part means FP T minus 4. Next part starts with the T equal to 4. 4A means 4. Next will start at 6 and etc. 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 So that means I can express my given signal. I can express my given signal as FPT plus FPT minus 2 plus FPT minus 4 till infinite term, FPT minus 6, FPT minus 8, etc. So what is the Laplace transform Fs? So see, what is the Laplace transform for 1 time period? Suppose it is FPS. Okay, suppose this signal, this 1 time period has the Laplace transform which is FPS. Okay, then what about the other one? Time shifting property only. FPS e power minus 2s. Time shifting T minus 2 to e power minus 2s. Next is FPS e power minus 4s till infinity. Till infinity, right? So FS is equal to, you can take FPS common, and then if you take FPS common, you will be actually getting a GP expression, 1 minus e power minus 2s, e power minus 4s, e power minus 6s till infinite terms. Okay, and for the GP with infinite terms, the answer is A, first term upon 1 minus common ratio, e power minus 2s, 1 minus r. Are they asking the ROC? No. Okay, but the point is, what is FPS? What is FPS? So let us solve here. What is FPT first of all? Can you talk about this FPT? See, can you talk about this FPT? FPT starts with the constant amplitude 1. Okay, constant amplitude means you can use the unit step, UT. Okay, constant amplitude 1 from 0. But if you only write UT, UT goes till infinity. So there is a change in amplitude. Okay, so whenever you need the change in amplitude, change in magnitude, you can talk about unit step signal. Change in slope, you can talk about unit ramp signal. So here the value changes from 1 to -1. How much is the change? From 1 to -1, how much is the change? -2. 1 minus 2 will give you -1. So you need to reduce the value -2 here. Okay, so -2 times unit step. But unit step at which point? This is t equal to 1. Okay, so ut minus 1. But again here at t equal to 2, you need to add the value. You need to add the value which is equal to, because here I stop the signal, make it 0. So -1 plus 1 will give you 0. So plus unit step. Okay, plus unit step. At which point t equal to 2. So u of t minus 2. U of t minus 2. Okay. So then what is FPS? Fine. Then you can complete. What is FPS? Okay. Unit step Laplace transform 1 by s. Then 2 unit step 2 by s, time shifting property e power minus s. And then again 1 by s, time shifting property e power minus 2s. Right? So I can substitute this here, and Fs is then equal to, what is the Fps? I'll take it as whole divided by s, 1 minus 2 e power minus s, 1 minus 2 e power minus s plus e power minus 2s is divided by 1 upon 1 minus e power minus 2s. See, the numerator is actually of the form 1 minus e power minus s whole square, a minus b whole square, a square plus b square minus 2ab. Look into it. A square, b square, e power minus s square, e power minus 2s minus 2ab. Okay, then upon s. And then this particular denominator term, you call it as a square minus b square. You call it as a square minus b square, right? Okay, so a minus b, that is 1 minus e power minus s into a plus b, 1 plus e power minus s. Okay, so one of these factor will get cancelled and your answer is going to be, now see, numerator is only a single term 1 minus e power minus s, denominator will contain 1 plus e power minus s and whole divide by s, whole divide by s. Okay, with little bit rearrangement here, with little bit rearrangement that I leave to you, you will match and you will get the answer as 1 by s tan hyperbolic s by I, tan hyperbolic s by 2. Because you can call the tan hyperbolic theta as sine hyperbolic by cos hyperbolic, and you can arrange the numerator and denominator in the form of hyperbolic functions. Okay, Shanti Swami, just message me in the Telegram once. I'll reply you with some sources where you can practice more with respect to what exam you also mentioned, with respect to ESE only or any other exam also. Okay, dear. So this is what it is. Okay, option number A. Option number A. Right. Option number A. Correct. Right, dear. Let's take up the next question then. Look into this question. Consider the LTI system whose response to the input xt is yt. What is the system's impulse response? First, what I can find the transfer function of the system. Correct, na? First, I can find the transfer function of the system. What is the transfer function of the system? Transfer function is the ratio of output Laplace transform. So what is given? The input is xt and the response, that is output yt, is given to you. The transfer function is given by, the transfer function of the system ts is given by ys upon xs, is given by the ys upon xs. Okay, ys upon xs. Okay, what is ys? Laplace transform 2 e power minus t 1 upon s plus 1 minus 2 e power minus 4t 1 upon s plus 4. Then now divided by xt Laplace transform e power minus t ut, so 1 upon s plus 1 plus e power minus 3t. Okay, so 1 upon s plus 3. Okay, so we need to simplify this. Okay, I'll do the simplification here actually. Okay, so it should be how much? See, rather, let me solve it here first. 2 common, s plus 4 minus s plus 1. So 3 will be there upon s plus 4. S plus 1 will get cancelled. Denominator s plus 3 upon s plus 1. 2s plus 4. Write it here only. Okay, so see, what is the numerator part? 2 I have separated. Okay, into 3, s plus 4 minus s plus 3 upon s plus 1, s plus 4. S plus 1 will then cancel. Denominator s plus 3 plus s plus 1. So 2s plus 4 upon s plus 1, s plus 3. Okay, then this is further equal to, now s plus 1 cancelled, 2 into 3, 6. This s plus 3, this particular s plus 3 I can take above, so 6 s plus 3 upon denominator. Denominator you can take 2 common. Okay, 2s plus 4, you take 2 common, so s plus 2, and then what else is there? This s plus 4. This s plus 4. So 6 by 2 will cancel. 6 by 2 will get cancelled, and the transfer function will be equal to, 3 s plus 3 upon s plus 2 s plus 4. S plus 2 s plus 4. 3 into s plus 3. Correct. Okay, now I have to break it into partial fraction, and I think it's an easy one only. 1 upon s plus 2, 1 upon s plus 4. No, it's not going to be 1 upon s plus 2 plus 1 upon s plus 4, but rather it could be, I want this as how much? This is equal to 3s plus 339. I want to make it 9. that was, oh sorry, s plus 2, s plus 4, correct only, na? 2 common, s plus 2, that was s2s plus 3, correct? Then s plus 1 only cancelled, s plus 3 I have shifted above, s plus 2, s plus 4. Okay, so 6 by 2 I have taken 3, 3s plus 3. Okay, if I directly add, okay, no problem, yes, see, got it. If I directly add this, na, if I directly add this, see, this becomes 2s plus 6. This becomes 2s plus 6, right? Upon s plus 2, s plus 4, and I want only s plus 3. Got this. So yeah, this should be equal to 3. I have separated 3 by 2. You make it 3 by 2. Okay, so that 2 will get cancelled. Correct only. Okay, so now what is the impulse response? Impulse response means the inverse Laplace transform of the transfer function. So what is the inverse Laplace transform? 3 by 2, 1 upon s plus 2, e power minus 2t, 1 upon s plus 4, e power minus 4t, whole multiplied by ut. So 3 by 2, e power minus 2t plus e power minus 4t, that is the option number A. That is the option number A to be tick marked. Correct? Okay, dear. Right. So this is the transfer function based question. Correct? This is the transfer function based question. Next question. A direct question. What is the bilateral Z transform of the given signal? What is the bilateral Z transform of the given signal? A power n plus 1, u of n plus 1. A power n plus 1, u of n plus 1. See this. A power n plus 1. See, so direct formula you can use now. A power n un. What is the Z transform for A power n un? 1 upon 1 minus A Z inverse. That's it. Okay, right-sided signal. So ROC is given by mod Z greater than mod A. Okay, so for A power n plus 1, okay, time shifting will now be applied. A power n plus 1, u of n plus 1. The Z transform will be n plus 1. So Z power plus 1 multiplied. Okay, n plus n naught, Z power plus n naught. That is a time shift property. So Z power 1 upon 1 minus A Z inverse. Mod Z greater than the mod A. Okay, so what is the correct answer? Option number A. What is the simple correct answer is the option number A. Okay, fine. Next question then. Okay. Sample xt at the rate of 10 samples per second. Okay, so sampling frequency fs is given as 10 samples per second. What is the ROC of the Z transform directly obtained from xn if the input xt? So see, what is going to be xt? How do you sample it? Okay, so when do you sample it? You get the signal xnts, sorry. The sampled version x of nts, okay, x of nts is equal to how much? So what is the ts? Ts will become 1 upon 10. Okay, so x of nts means x of n by 10. So what is the discrete time signal to be created is minus 2 e raised to the power minus 3 by 10 into n plus 3 e raised to the power minus 4 by 10 into n. Okay, I need to create xn by 10. So 3 by 10 into n, 4 by 10 into n, whole multiplied by u of n. U of n by 10 will be same as un. And now the only question is ROC. Okay, so see, this is again of the form a power n un, dear. For a power n un, just now in the previous question also we saw ROC is mod z greater than mod a. So what is the ROC for this? Mod z greater than mod a. Okay, how you can write this? You can write this as e power minus 3 by 10 whole power n. This is your a power n. How you can write this? E power minus 4 by 10 whole power n. This is your a power n. So mod z greater than modulus e power minus 3 by 10. For the next one, mod z greater than e power minus 4 by 10. This is more negative power. So this is going to dominate. Okay, this is going to dominate. So now let me tell you what are these values. You want mod z greater than, how much is this value? 0.7408 or 0.74 approximately. And this one will be smaller. You need to take the intersection anyways. But this is going to be smaller because this is more negative power. But still, I'll write down the value. This is 0.67. This is 0.67. Okay, so you want mod z greater than 0.74 and also greater than 0.67. So it should be greater than the greater number. So 0.74. It should be greater than 0.74. Mod Z greater than 0.74. Answer is D. Answer has to be option number D. Okay. Answer has to be option number D here. Mod Z greater than 0.74. Okay. Next question. Okay. 2016, a statement question. Okay. Consider two-sided discrete time signal, which is neither left-sided nor right-sided. That is why we call it as two-sided. What is the ROC? Now, ROC for two-sided signal. ROC for two-sided signal is a ring in the Z plane, okay, between two poles. Okay, it is of the form Z1, okay, mod Z between two poles Z1 and Z2. Okay, so it is ring in the Z plane. So what is the only statement correct is 3. Okay, right. Inside or outside comes when you have a right-sided, okay, and left-sided signal. If it is a right-sided signal, then exterior ROC, left-sided signal, interior ROC. Okay, but here two-sided signal means it's a ring in the Z plane located between two poles. Okay, the correct answer is, the correct statement is only 3. Is only 3. Okay, that's what it is. Okay, correct statement is only 3. Fine. Next question then. A discrete time LTI system with the rational transfer function Hz is causal if and only if. Is causal if and only if. What is the condition for a system having the transfer function Hz to be causal? Okay, the causal means what? Causal means impulse response is right-sided. Impulse response, which you usually call it as Hn, is right-sided. So the transfer function, because what we know, Hn and Hz are Z transform pair. Impulse response and transfer function of the system are Z transform pair. Okay, transfer function is the Z transform of impulse response. Okay, so transfer function, because signal is right-sided, so what should be the transfer function? Transfer function ROC will be exterior of a circle. Exterior of a circle. Okay, so it is the exterior of a circle. Outside what? Outside the outermost pole. It has to be exterior of a circle outside the outermost pole. Because ROC cannot include any pole. If you take ROC exterior outside the innermost pole, then the other poles will come in the ROC, which is not possible. Okay, exterior of a circle lying outside the outermost pole. This is a standard result. If you have studied Z transform, okay, if you have your notes also, this is a direct notes question, nothing more. 2021 question, direct notes. Okay, 2021. Have a look into this question, 2021. Okay, so it's on solving the difference equation. Okay, the zero input response. Input is not given, and that is why we call it as zero input response. The response due to the initial conditions, the natural response of the system. Okay, now first of all, what is the Z transform property to be applied here? Converting to the Z transform, dear. See, what is the difference equation given? Yn minus 3yn minus 1 minus 4yn minus 2 equal to 0. Converting to the Z transform to solve it, yn Z transform, yz. Minus 3. Now, what is yn minus 1 Z transform? Yn minus 1 Z transform with non-zero initial value is given by Z inverse yz, Z inverse yz plus y minus 1 plus the initial value y minus 1. Okay, minus 4. Now, yn minus 2 Z transform. I'm just writing the standard property first. Will be Z power minus 2 yz plus Z power minus 1 y minus 1. Okay, plus y of minus 2. Okay, and equal to right side 0, so Z transform also 0. This is the property. Now, I will start collecting the terms. What is the data given to me? Y minus 1 is 5. So, this y minus 1 is 5, but y minus 2 is 0. Y minus 2 is 0. Okay, so that means yz, first of all, let me take common. So, 1 minus 3 Z inverse, and from here you will get minus 4 Z power minus 2. Then minus 3 into 5 minus of 15, and then minus 4 into 5 minus of 20 Z power minus 1 equal to 0. This term is not required. Okay. So, dear, what is going to be the yz? What is going to be the yz? You shift the terms on the other side. 15 plus 20 Z inverse upon 1 minus 3 Z inverse minus 4 Z power minus 2. I can factorize the denominator as Yes, minus 4 and plus 1. Look into this. 1 minus 4z inverse into 1 plus z inverse. Why? Because if you open minus 4 plus 1 minus 3z inverse, minus 4 into 1, so minus 4 z power minus 2 total. Correct. Okay, and then you will split this into partial fraction, some particular term upon 1 minus 4 z inverse plus or minus some particular term, okay, upon 1 plus z inverse. Now, you can solve the partial fraction, but I don't think it is going to be required fully. Because if you match the option, see, if you match the option, this particular term, 1 upon 1 minus 4z inverse should correspond to 4 power n. 1 upon 1 minus az inverse, so 4 power n, a power n. And 1 upon 1 plus z inverse. Okay, 1 upon 1 plus z inverse. So you can assume this particular term as how much? This is 1 minus of minus z power minus 1. Okay, so 1 minus az inverse. What is a? Minus 1. What is a? Minus 1. So what is a power n? Minus 1 power n. So these two terms should be seen in the options. These two terms should be seen in the option. Okay, 4 power n. Now 4 power n plus 2 can come because when you solve it, maybe some, z term is coming up here. Maybe some z power plus 2 minus 2 is coming, which will correspond to time shifting. Let us discard. If possible, let us discard. Okay, so do you have any common option which includes 4 power n and minus 1 power n? Okay, see, minus 4 power n will not come. 1 power n will not come. Yes, 4 power n and minus 1 power n. Okay, option number C. Option number C it is going to be. Rest you can discard actually. Rest you can discard. You can, if you want, you can solve the partial fraction, but not required. We can solve it quickly. That is what the objective should be, I think. Correct, na? That is what the objective should be. Okay. Next question. What is the particular solution of the difference equation? Now see, it's on only the particular solution, okay, corresponding to the forcing function. Okay. Now, see, there are two methods of solving here. There are two methods of solving here. Method number 1. Okay. Okay. Solve completely by Z transform method. Okay. And split your output yn as the ycn plus ypn, the complementary part and the particular part. Okay. And this is what you have to figure out. Method number 2, simple logical method. Method number 2, simple logical method. See, anytime what we know for LTI system, okay, for LTI system, see, what is the input of the form? Method number 2, input is of the form 2 power n, or suppose whenever the input is of some form alpha power n or of some form a power n, okay, then how is the particular solution to it given by? The solution, okay, the particular solution corresponding to it is given by, okay, the particular solution corresponding to it is given by k a power n. It is in the form of a power n with some constant multiplier, okay. If I just use this philosophy, okay, so what is my given equation? See, what is my given equation? Yn. So yn means output. The output k a power n. Okay, what is a here? What is a here? 2. The input is 2 power n. So k into 2 power n is equal to k into 2 power n. That should be my output, is equal to 5 by 6 yn minus 1. So if yn is k a power n, the output, the n minus 1 will become 2 power n minus 1. Okay. Minus 1 by 6. Yn minus 2. So write down yn minus 2. K a power n minus 2. 2 power n minus 2. And plus input xn. Input xn means 2 power n. Input xn means 2 power n. Okay. So now very clearly 2 power n I will cancel everywhere. 2 power n if I cancel, I will have k equal to 5 by 6 k 2 power minus 1. 2 power minus 1 is left. Minus 1 by 6 into k, 2 power minus 2 is left. Plus 1. Okay, plus 1. Okay, so you have to solve this. Bring all the k terms on one side. So 1 minus 5 by 6, 2 power. This is 1 by 2. So 5 by 12 actually. And this minus minus plus. 2 power minus 2 in the denominator, 4. So 6, 4, 24. So plus 1 by 24. This should be equal to 1. Okay. So solving from here, k into 24 if I take common. So 24 minus 5, sorry, it should become 10. So 14 plus 1, 15. Okay, so k solving from here is actually 24 by 15. If you cancel 3, it should be 8 by 5. Okay, so 8 by 5, whatever is the correct answer, yes, see, it should be k a power n. Okay, k is 8 by 5, a was 2, so 8 by 5, 2 power n. Okay, this is a simple way of solving the question. Because if you solve it completely by Z transform, then splitting into inverse Z transform, splitting into partial fraction, then calculating inverse Z transform will be definitely time taking. Okay. Right, but because they are asking particular solution, okay, so they have not given initial values, so initial values will be taken as 0. All y minus 1, y minus 2 required will be 0 if you are solving fully. If you are solving it fully. Correct? Right. Okay, dear. Okay, guys. So, yeah, quick updates for you that May 29th, tomorrow. Okay. That is tomorrow. The new offline batches for GATE. The new offline batches for GATE 2026. The long term as well as the short term course begins tomorrow. Only thing is, in the long term, okay, the fee is 54,999, but in the long term, you study all the subjects in the offline manner. Everything in front of you, complete syllabus in the offline manner. In the short term course, I mean, so if you can stay in Hyderabad for long term, this is the advisable course for you because everything you study in offline with the best faculty team of ECEE. If you cannot stay fully in the Hyderabad for long term, okay, maybe you have college semester break, you can spend some 2 months or by some means you can come to Hyderabad for roughly 2 months. Okay, 50 to 60 days also if you can manage, you can cover at least 50% of your syllabus. Okay, so yeah, yes, important point, roughly 50% of the syllabus you can cover in offline. That will give a boost to your preparation definitely. Okay, because in small span of time you cover subjects in full depth only. Okay, that too in the offline manner. So when you study live in front of the faculty, you will be getting very, 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 very good understanding. For rest of the subjects, you will be given the complimentary access to our online courses. Yes, so after the 2 months, you can study the rest of the subjects in the online manner, live or recorded, anything you want. Okay, so that will be complimentary included in this fee. So for short term, the fees is 45,000, including the 2 months, that is 60 days of offline class plus the access to live course that is available till GATE 26. Till GATE 26, it will be available. Okay, some special discounts are mentioned in front of you. And by any chance, if you can't travel to Hyderabad, you feel no, it's not possible for you to travel to the Hyderabad and you want to still study by the best faculty team, same content, same faculties, you can take the online live course. Okay, you can prefer the live course so that, at least one-on-one doubts you can, it's more or less will give you some feel of offline because faculty is live in front of you. Immediately you can discuss any of the things you have. This particular batch also starts from 29th of May. Okay, the fee for 1 year, that is GATE 2026. Here you have both the option, GATE 26 and GATE 27. Okay, for GATE 26 with 1 year validity, the fee is 99.99. For 2 years validity, it is 28,999 for GATE 27, right? Okay, dear. And if you are preparing for any of the AE or AEE examination with respect to, maybe AB Transco, AP Discoms, TG Transco, TG Discoms, the new offline batch, okay, starts June 2nd. Starts June 2nd. Okay. For any more queries, you can contact 95156 94053 and yes, get any of your doubts rectified. Okay. As my other sessions, I will share you the PDF of this session. Okay. PDF of this session will be, the password will be solution. Some solution of Z transform we were looking at. Everything in small. I'll keep the password protection to the PDF so that yeah, those who put the efforts to watch the video, those who are learning, the notes are useful only for them. Because if you have watched, then only you can follow the notes. So for that reason, I'll put the password, everything in small, solution, which I will share. Okay, which I'll share in this particular Telegram group. Okay, dear. This is Rakesh Talreja signing off. Bye bye. Thank you. Stay safe and all the very best. Keep preparing hard.